Number 12. Right back at it. All right. So number 12, they're asking me how many neutrons in the most abundant isotope of this. Well, first I have to know what this is. So that's skill number 1. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, 19, 20, 30, 36. 36 electrons. So the first thing I'm going to do is go to my periodic table and see what has 36 electrons. In this case, it's krypton. Oops, got that glare going. 36. So this is krypton. Good to know. And they want to know how many neutrons in the most abundant isotope. Well, the most abundant isotope, if I round this and make it a mass number, right now it's an atomic mass. It's the average of all the isotopes. But I need one specific isotope, the most abundant. The most abundant is this, rounded into 84. So 84 is my mass number. That's skill number 2. Now, number 3, I need to know what a mass number is. A mass number is protons plus neutrons. Now, they're asking me about neutrons. So how do I get the neutrons out of this mass number? Well, I could subtract out the protons, and then all that would be left was the neutrons. Skill number 4, how do I know where the protons are? They are the atomic number, 36, so 84. The mass number, 84, minus 36 protons. Mass number minus 36 protons equals 48 neutrons. This has 48 neutrons. Remember, neutrons have no charge, so that's what that 0 is there for. Ooh, why did I say the protons have 0 charge? Bite your pencil, sir. Protons have a positive charge. Okay. So that's how we figure out the number of protons, number of neutrons. And let's see, now I got it on the brain. How many neutrons are in the most abundant isotope? So let's just keep on going. So here they're just asking me, what is this element again? 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 30, 36, 38, 48, 49, 50, 51, 52, 53, 5, 6, 66. So what is element number 66? It is dy it's dy. I need some reading glasses if I'm going to do that. All right. And then the next one, 2 plus 2 plus 6, 10, 12, 18, 19, 20, 25. 25 is manganese. Manganese, good old manganese I know the name of, right? Yeah, never mind. Okay. And now again, they're asking me number of valence electrons. Even if it's in this form, it doesn't matter. What is the highest shell number achieved? The highest shell number is 5. And in that fish shell, I have 2 electrons plus 3 electrons. I have 5 electrons. And then they're asking me another number of neutrons in the most abundant isotope. Okay, so argon. First, I have to know what this element is. So it's argon, how many ever electrons that is, plus 1, because I have a 4s and I have a 1 here. So argon has 18, plus 1 is 19, so I am dealing with potassium. Potassium, I'm going to write that right here. I'm dealing with potassium, right? And I know that the most abundant form of potassium is potassium 40. So K40. And I know, oh, sorry, did I say 40? Dang, now I'm doing my students' mistakes. 39.1 does not round to 40. 39.1 rounds to 39. Most abundant isotope of potassium is potassium 39. I need to rewind all that nonsense that I just said, all that lying, and not lie. It's 39. 39.1 rounds down. I'm getting a little slap happy. It's a little late in the day. But I promised, so I'm going to be a man of my word. Okay. So, number of neutrons in the most abundant, so 39. So I just subtract the number of protons, which is 19. 39 mass number minus 19 atomic number or protons, or whatever you want to say, equals 20 neutrons. That's it, 20 neutrons. All right, Lewis dot structure. This is so easy. Now, I'm going to not do bromine and neptunium. Iron and neptunium. The reason is because one of them's way down here, and one of them's right here in the transition metals. Transition metals, there's no easy way to know how many valence electrons. So I had you look on your previous sheet, which you can do. I can turn this sheet over. I can go to iron. I can go, the highest shell I have is 4. And it has 2 electrons in it, and I could just do a Lewis dot for 2 valence electrons. But the better way is to go sodium, Na. It has 1 electron because it is in group 1A. So my Lewis dot, 1 electron, 1 valence electron. Remember, we're only putting valence electrons in Lewis dot. We only care about bonding, and only valence electrons bond. So as far as you know. Bromine has 7 valence electrons. Remember, we do 2 on each side. And then 1 on the remaining side. That's 7. Barium. Barium is right here. It has 2 valence electrons. And right now, I don't want you to worry too much about where you're putting your dots. In the future, we will worry about that. Right now, as long as it has the correct number of dots around it, I'm okay. Okay? Okay. All right, in the space below, write the noble gas abbreviated electron configuration of the following elements. Now, there's a couple ways to do this. Usually, what I do is I write a big, long electron config, right? And so I'm doing cobalt. So for cobalt, the first thing we do is we go backwards. God, I hate this glare. We go backwards until we get to a noble gas. So 27, and 26, 25, 20, and 19, and then I go up to 18, argon. Argon, if I go backwards. Remember, I have to go backwards. 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, argon. So the first thing I'm going to do is AR and brackets. And then I'm going to note how many electrons that dealt with. That dealt with 18. And cobalt has 27, so I have another 9 electrons I have to deal with. So I'm going to put that out to the side. I got to deal with 9 electrons. I dealt with 18. Now, argon is in 3s_p6. So the last part of argon is 3p block 6. And they all are. They're all going to be p6, right? So I know that if this is 3p6, then I can take this and start going again, right? 3p6, so 4s2. And remember, I have to deal with how many electrons? 9 more. And then I go from 4s to 3d, but I don't need it to hold 10. I only need it to hold 7, 8, 9. I only needed to deal with 9 electrons, right? So this is it. This is the complete abbreviated noble gas abbreviation of cobalt. Now, there's another way to do it. I can go to argon and go argon brackets, and then go down and go, all right, now I'm going through 4s2, then 3d, 1, 2, 3, 4, 5, 6, 7, 3d7. Oh, it does end on 3d7. So I can write just from argon and go 4s2. 3d, you just have to remember that this is 3, this is 4, then we get some weirdness down below. But anyway, silver, so we're going to here, right? So I go backwards, I go to krypton, so I have krypton, and that takes care of 36 electrons. Silver has 47, so I need to deal with 11 more electrons. And krypton ends at 4p6, so I know the last part of that I'm starting at 4p6 and going from there. So 4p6, 5s2, and then 5s2 up to 4d10. Oh, I don't need it to hold 10. I only need it to hold 9. 5s2 and then 4d9. All right, let's see if it holds true. So we're going from krypton, right? And we go krypton, 5s2, and then 4d, 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute, I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there it is. So I didn't go from the edge of the D block. This is 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5s2, 4d9. That squares with what I know. That squares with doing it with the off bow, so I'm happy with my answer. Determine the elements denoted by the following electron configs. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. 16 is sulfur. 2 plus 2 is 4, 6, 10, 11, 12, 18, 19, 20, 30, 36, 37. 37 is rubidium. That's fairly easy, right? All right, that's page 1. Let's keep going. Page 2. All right. Hang on, I'm going to do a third part to this video, and we're going to end strong on that third part.